We are going to look at properties and preparations of alkanes. Okay, properties and preparation of alkane. Now, what are the physical properties of alkane? Physical properties of alkanes. Number one, alkanes with 1 to 4 carbon atoms are gases at room temperature. Those with 5 to 16 carbon atoms are liquid at room temperature. Paraffin here is another name for alkane, which is paraffin. Okay? In the next video, I'm going to tell you why alkanes are known as paraffin. Paraffin means little affinity, all right, which shows that alkanes are very less in reactivity. Some textbook will tell you that alkanes are not reactive, or maybe alkanes are unreactive. Please, it's very wrong. Discard that. Okay, alkanes are reactive, but it's very less in the tendency of reactivity. All right, the name para means little and affinity means ability to accept electron. So the tendency of reactivity of alkanes are very low. So I'm going to elaborate more on that in the next video. Please don't forget to subscribe to the channel. Then those with 17 and above are solid at room temperature. Those alkane with 17 carbon atoms and above are solid at room temperature. Okay, now the second point is that alkanes are non-polar. Alkanes are non-polar. Hence, they are insoluble in water. They are insoluble in water because water is a polar solvent. Water is a polar solvent. Okay, being a polar solvent, alkanes which are non-polar can never be soluble in water. Okay, hence these non-polar alkanes, they are soluble. Alkanes are soluble in non-polar solvents such as kerosene, benzene, and fats. Okay, alkanes are non-polar. They are insoluble in water, but they are soluble in non-polar solvents. So non-polar dissolves non-polar. Polar dissolves polar. Do you understand? Okay. Then number 3. Some of their physical properties such as boiling point, melting point, molecular density increases as the number of carbon atoms increases. Okay, and this is due to increase in covalent bond and van der Waals forces. Okay, as the number of carbon atom increases, there is corresponding increase in boiling point, melting point, and molecular density. Okay, as a result of increase in the number of carbon atoms. Okay, then I told you that this increase in boiling point, melting point, and molecular density that arises when the number of carbon atom increases is due to increase in covalent bond and increase in van der Waals forces of attraction as the number of carbon atom increases. Okay, I've discussed this point here in the last video. So these on the board are what we have here on the properties of alkanes. Now let's look at preparation of alkane. We are going to look at how alkanes are prepared in the laboratory and how alkanes are prepared in the industry. Here we are going to look at laboratory preparation. Let's look at laboratory preparation. Okay, in this preparation, you heat, that is a mixture of sodium ethanoate, sodium alkanoate, and soda lime, a mixture of sodium alkanoate and soda lime, this is soda lime, is heated in the test tube and gases are collected over water. Okay, the gases collected over water can be methane, it can be methane gas, it can be ethane gas, it can be propane gas, then it can be butane gas. Do you understand? Because 1, 2, 3, and 4 are the examples of alkanes. Okay? They are examples of alkanes that exist in gaseous states, which we've taught in the other video. Now let me show you the diagrammatic illustration of this. Here is reactor stand. Here is the test tube. Containing the mixture This is the mixture of sodium alkanoate. The sodium alkanoate can be written like this. This CH3 here is the alkyl group, okay? And soda lime, which is sodium hydroxide, okay? Then this is collected into another container that contains water molecule. Here is your collecting cylinder, okay? To filter, this is water molecule. You can call this H2O, which is water. Here is your gas jar. Here is the gas jar. Here is water also. Then here is methane gas. Methane is the lightest organic gas, okay? Now, the gas here is collected over water, all right? Because it is lighter than water, okay? Or less dense than water. So here, after heating, here we apply heat. Here is the heat. This is heat. You heat the mixture of sodium alkanoate and soda lime. Here is the mixture of sodium alkanoate and soda lime. When you heat it, the gases will evaporate. The gases will evaporate and is collected into this container that contains water. As the gases enters into the container which contains water, the gas is collected over the water because it is less denser than water. And here a methane gas is obtained. This is methane gas. Okay, let me illustrate again using the chemical symbol. Sodium alkanoate, sodium alkanoate reacting with, that is a mixture of this and this, sodium hydroxide. Here is soda lime. You apply heat, okay? It's going to give you sodium triosocarbonate and methane gas. Here is methane gas, okay? Then here is sodium triosonitrate and methane is obtained. One of the chemical preparation, that is laboratory preparation of methane, that is alkane. Okay, now the next we are going to look here is the industrial preparation. All right, because of space, that's why I'm wiping the board. Okay, all right. This industrial preparation of alkane employed a chemical process known as hydrogenation of alkene. All right. This is, or this involves the chemical process known as hydrogenation of alkene that occurs in the presence of nickel or platinum as a catalyst at a temperature range from 160 to 200 degrees Celsius. This is the temperature at which the chemical process occurs. All right, and don't forget I said that hydrogenation takes place in the presence of catalysts which are nickel or platinum. These are the two catalysts involved in this hydrogenation process where alkene are now used to produce alkane. Now, alkene, as we know, possess weak pi bond. This is alkene, okay? Do you understand? Okay, or let me draw the full structure. Let me draw the full structure. In the presence of nickel or platinum as a catalyst at a temperature 200 degrees Celsius to produce alkane. This is alkane. Okay, here is alkene. Do you understand? Then here is hydrogen gas. Now, that means that alkene are used industrially to produce alkane through a process known as hydrogenation that occurs in the presence of nickel or platinum as a catalyst at a temperature range of 160 to 200 degrees Celsius, which I illustrate on the whiteboard. Please, like I told you before, the process or the chemical process involved in the industrial preparation of alkene on the board is hydrogenation, all right, which occurs at a temperature range 160 to 200 degrees Celsius in the presence of catalysts. The catalysts are nickel and platinum. Okay, please, this is all we have for now. Don't forget to subscribe to our channel. More videos on organic chemistry are coming. Please drop your questions in the comment section. Subscribe to our channel. Thank you and God bless you.